going to move the entire. So I am going to use move object lorry, right? Very good. So then I am moving to here and moving. Then I am moving here, right? Okay, I'm moving here, right? Okay. So now I have drawn some diagram. Okay. Now, next what I have to do? Yeah, let me. So I have to draw this line. This is a double-edged arrow. Double-edged arrow. It is my somehow my mouse is not doing some double-edged, but it is a double-edged arrow. Right. Very good. So now I'm going to draw double-edged arrow. So here I have a double-edged arrow. Double-edged arrow means correlation. Double-edged arrow means correlation, right? So otherwise covariance, right? Covariance, right? Okay. So now whenever you put a covariance, error is not necessary. But whenever you use one arrow, it is a influence, right? We are determining remaining error, right? Okay. So now that touch tool, right? Touch tool, right? I'm making this one, make it attractive. Okay. So touch tool, right? Okay. No arrow. So now my drawing is over, right? Okay. Now my drawing is over. Now I have to link with the data. Now,
Sir, sorry to disturb you, sir. We can't able to see your screen, sir. We can see your audio video, but your screen is not shared with us, sir.
Arun sir.
Sir.
Sir. Yeah, can you see, sir?
I have pinned your screen, that's why I can see. But if you can stop the presentation and present once again, then all will be able to see, sir. So if you do once again, people will be able to see. But I request the audience to just go to sir's PPT and pin it. You can see it.
Now, okay. Now I will do. I don't mind do any number of times. Okay. So, but I have to complete. Please help me. Please help me. Okay. So, okay. Now what I will do is, okay. So I will do again. Let me do one more time. Okay. So let me do one more time. File. Let me not save. Okay. Let me not save. File new. I have a new. Okay. Now let me go there. Okay. Let me do. Already it is there. Presentation mode only. It is there, right? So shall I stop presenting and shall I do it again?
Sir, if you do that, no, then everybody will be able to see.
Okay.
Because many people are not comfortable with pinning.
Okay. Now, okay. I will stop the sharing. Okay. Then let me present now. Okay. Entire this one. Okay. Entire one. I am sharing now. Okay. I am sharing now. Now my presentation is coming, right? Okay. 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 Now. Okay. Now, madam.
Yes, sir. It is visible now. It is visible now. You can continue. Yes.
Right, sir. Yes, sir. Yes, sir. Very good, sir. Okay. Now, some people. Okay. So since
it is visible now. You can continue.
Something may not be that much visible. Now, so now let me draw bigger size diagram.
It is visible now. You can continue.
Something may not be draw bigger size. So now let me draw bigger size. What is bigger size?
It is visible now.
I'm drawing like whatever I may not be draw bigger size. Little big so that everything. Okay. Now. Okay. Now I'm drawing like so I request that madam to still the help of somebody else in their house, right? So that is not so I request that madam to still the help of somebody else in their house. Okay. So I've drawn, right? Very good. So now let me somebody else in their house. Symmetry already there. So I'm rotating, right? Very good. So now let me this is what I have to do. I'm rotating. Okay, I have rotated. Okay, wherever I want to keep. Okay, I'm keeping. Right, okay. Okay, very good. Okay, now the rotation is over. I'm moving with a lorry. I'm moving. Okay. So please remember that your diagram should not go away from the screen, right? If you want to have bigger size diagram, then view interface property, page setup. Okay, but now I need to have this side long, this one. That is why I'm keeping it as it is, right? Okay, so that depends upon the requirement, right? Very good. My job is over. Now I'm using this double-edged arrow. So that is called covariance line, otherwise correlation line. This one, right? So this, now I'm drawing this one, right? Very good. Okay, now that drawing over. Now let me tell again. Here, since it is a covariance double-edged, both side arrow is there. So since I'm using both side, I'm a relationship only, not determining. So there is no necessity for error. There is no necessity for error. Okay, that job is over. Okay, now I have to link with the data. Now I have to link with the data, right? Okay, now the data linking. Okay, that Excel I'm clicking. File name. I'm clicking file name. I'm going to the file. So I'm going to use that restricted supply chain. What is restricted supply chain? Means supply chain only data we have taken a limited data. Okay, so that is why it is called so structural equation modeling, CFA, restricted supply chain, restricted supply chain. So I have given one data set by name restricted supply chain. I am going to use that. Okay. So I have to say okay. Don't forget. I have to say you please sure that this restricted supply chain has come 150 data. We have 150 data. So let us say okay. Let us say okay. If you say okay, fine. Now here you have to see list of variables in data set. You go there, then you'll get like this, you'll get like this, right? Okay. Now this is my concern, supply chain concern, right? Supply chain concern, we got 5 items. Supply chain competence, we got 4 items. Supply chain performance, we call it as 3 items, right? So I'm going to place a supply chain 1 here, okay, 2 here, right? Okay, now I have told you, now it is coming like this. Now I do not want to have label. How to do label? Right click, object property. Here in the label, only name is compulsory. Label is not required. If you remove the label, that will go away. Now you can see here that is gone. Now, if you do one by one like this, it will take lot of time. Okay, so what to do is view interface property, miscellaneous, display variable labels, close it, apply, then it will go away. All right, very good. Now, if I do this one, okay. So, okay. Now, for example, I put this one under 4 itself. That will go away. 4 will go away, 5 will come. Right, okay. So now I want to have, if you committed mistake, what would I am telling, right? So 5 here. So if you have committed any mistake, wrongly placed, you place the right one, it will go away. You place somewhere else, cut with the scissor. Okay, cut with the scissor. Right. So now I am placing it here. Okay. So third one, fourth one, then there's SCP-1, SCP-2, SCP-3. Okay. Okay. Now that is over. Now, okay, I have to give a name. This is a latent variable. Okay, I do not have directly data. I have direct data for this one. This is my observed variable. Okay, rectangle observed data I had. That is why list of variables come. I have placed. Now for this, I do not have data. This is my factor dimension. Otherwise, a latent variable, right? So this if I see the name, I do not have any other name, so I can give any name, right? Variable name, not label. So let us put a con. right? I'm putting my laptop. O will not work. Okay. So now supply chain competence, we can put it as SOMP. Okay, I'm writing COMP. Okay, then for this one, what I'm doing, I'm keeping that. Okay, object property. Let me do it again. Okay, right click, object property, right click, object property, right? Then you can do the name. So this is called yes, supply chain. Yes. Right. So now over. The naming is over, right? Well, so now these errors are unnamed. So this is also some latent variable only. Whenever circle, right? So go to plugins, name unobserved variable, latent variable, right? All names. Okay. Now my drawing is over. Now my drawing is over. Very good. So now analyze property. Okay, analyze property in the output. I'm clicking standardized. I'm clicking correlation estimates. Okay, so why I'm clicking correlation estimates? I need this correlation, right? I need this correlation in the output. That correlation I want, right? That is why I'm clicking standardized and correlation estimates. Done. So now what drawing over, naming over, data linking over, analyze property over. Now I can execute. Now let me go to calculate estimates. Now, okay, it is coming. It is coming, right? Okay. So now, yes, let us put the 5. Yes, 5. So I have saved. Now, here I want to, I do not know how many people really they have tried in their home, right? They have not given me what are the problems they had. So the problem what they have is, for example, yesterday we had one variable unnamed that will be there, which means, okay, some of the variable you have clicked many times, some variable is inside. So now these are all variable, we have given name. Some variable without your knowledge, it is inside. So where that name variable for is unnamed. So what to do is, don't search for this one. You go to file new, you go to new screen and start drawing. That is the simple solution. Then sometimes you will get error, it will not save. So that time what to do is first save, then calculate estimates. That will solve some of the problem. That will solve some of the problem. So these are all the two common problem you will have, right? Very good. So now estimates have come. Now this one is ready. Now this one is ready. Okay. Now let us go to view tax. Okay, so now in the view test, I'm searching where's our output, but here it is there. The top it is in a small. So if I maximize, the screen will come here. So now estimates. Now you know. Okay, this is your unstandardized. This is your standardized. So we have asked you to put the correlation, and you will get the correlation now. Now you have a correlation, right? You have a correlation. Okay. So now all over. Now let us see what we have done. Right. Very good. So this is what we have drawn. Right. In the analyze property, we have clicked the correlation. Right. So now this is the output we have. Output we have. Now what I am going to do is, okay, this is the standardized. Okay. So this is the output. Now let us show that output. Right. Okay. Now. Okay, so now that output also let me show. Okay, then I will come here. Now, this is my correlation. This is my correlation. Okay, this is my standardized. This is my unstandardized. Now, model fit. Okay, model fit. So, model fit C mean value is 74, degrees of freedom 51.016, 1.468. 1.468. Okay, now these are all the information, right? So now if I go to the diagram, okay. So this is my unstandardized because the error values are there. Okay, so if you click this standardized, you will get like this, or you will get like this, right? So now I'm going to show the output, right? I'm going to show the output in the screen, right? Very good. Now, okay. So this is my unstandardized. This is my standardized. Right. Very good. Now I have some table. I have some table. Okay. So now let me request somebody. Please, Arun sir, don't tell. Some people, those are don't tell. Let others tell. Right now. Yeah. Now, please, Christo sir, ask somebody to give answer. What do they see? What do they infer from this output, sir? So now we have some two tables. I feel those two tables are very very important table, right? I have four tables. We will come all the four. Now here we have two tables. Now what to infer from this table? Right. Very good, sir. Yes. Over to participants, please. Yes, quickly, sir. No time, sir. I have to draw one more diagram, please. Yes, sir. Please, sir.
Value.
Yes, sir. Hello, please, sir. Start.
Let me try, sir.
Please. Please try. Sir, this is trial, sir. Even if you make mistake, no problem, sir.
Yes,
We are here to learn, sir. Sir, you may be professor, sir. No problem, sir. Here we are learning. We have come here to learn, sir.
C mean we have to see.
Yes.
In that default model is our model.
Yes.
Look at that. And p value we have to see, that is the p value should be more than 0.05. Then
Very
we can
good.
say that model is fit.
Very good, sir. Very good, sir. Very good, sir.
But in this case, since it is less than 0.05, so model is not fit. Our model is not fit.
Okay. Then.
Murli sir, you can answer.
Then the next table, sir, RMR and JFI.
No, sir. Say okay. Sir, please. Anybody else? Next. Very good, sir. Next. Quickly. Another person? Yes, sir. What you have to see next?
Degrees of freedom, sir. 78 minus 27 is degrees of freedom. 51 we get.
Okay, sir. Okay. Now I will tell you, sir. Okay. Now we have to look at this p-value. This p-value is the p-value for C min. What is C min is chi square minimum. Chi square minimum. Why chi square minimum is here we are using chi square for model fit. Whenever you use chi square for model fit, it should be minimum. It should be minimum. That is why we call it as chi square minimum. Okay. So this is some value. We may not come to a conclusion whether that value is big value, small value, though we require minimum. So we look at the p-value associated with chi square. So this is the degrees of freedom associated with chi square. This is p-value. These three are one group, right? All associated. Now we are, since this is more. Now this is influenced by degrees of freedom. That is why we are going for normed chi square or relative chi square. Relative or normed chi square. Normalized chi square means C min value divided by degrees of freedom. So 74 divided by 51, it is 1.468. Now if this value is less than 2, it is a perfect fit. It is very perfect, very perfect. So even if it is 3, very good. Okay, even if it is 5, we accept. Less than 5, we accept, right? If it is 2, it is a super fit model, right? Okay. So I have told you this is very rare, very rare, right? Exceptional, right? So all features are satisfied. That is not possible, right? So even if this is okay, it is okay. we can stop there. We can stop there, right? But whenever we have we reporting, let us report something more which are favorable, nothing wrong, right? So now here RMR is not favorable to us. GFI, it is very good to us. GFI is 0.924. It should be more than 9. So we got, it is more than 9. That is good. Okay, now we are going for comparative fit indices. In the comparative fit indices, we have IFI more than 920 and CFI 0.916. Okay, so now this is okay. Now I'm going for RMSEA. So this should be compulsorily, it should be less than 0.1. It is good to have less than 0.08. It is very, very too good to have 0.05. Okay, if it is 0.05, 0.08, something like that. Now we look at the P close. This P close is associated with RMSA. All are associated with RMSA. So, meaning if you go to even at higher level of RMSA, okay, 90% higher level is 0.082. Lower level is 90% lower level, right? And if you plot all RMSA value, right? Okay, lower level 0.025, higher level 0.082. So our P close is 0.338. It is more than 0.05, which means RMSA. Okay, we say that that is a close fit. That is a close fit. P value for close fit. It says that. So though RMSA is 0.056, but it says that it is a close perfect fit. Okay. So these are all the things we will look at it. Now, for CFA also, we have to see. CFA also, we have to go give this thing, right? Okay. Now, this is okay. When this is okay, how we are telling okay? P close is good, CFI is good, okay, IFI is good, GFI is good, C mean by degrees of freedom. We have so many, right? Even this itself good, it is pakka. We have some other factor also to tell our future model is good. Okay. Now even one GFA value is good, okay, no problem, right? So mainly you have to look at this value, and RMSCA value, right? Very good. Now we say model is good, yeah, model is good. Now when the model is good, we are going to use, okay, today we are going to use standardized regression weight and correlation, right? In AMOS, we cannot rely upon unstandardized. That we will use it to find out only p-value, whether the path is influencing or not. Okay, mainly we look at that because here in most we have some problem. What is that problem is, what it will do is normally see can't 0.52 here 1.30, which means it is that con 3 is fitting more than 130%. We cannot have. But how it is happening? Because it presumes the bottom line is 1. It presumes bottom line is 1. When this is 100%, what is the percentage it is going? Okay. So that is why, so interpreting the unstandardized loading is very tough. Unstandard. That is why we use standardized. In a standardized, nothing will be more than 1. Then that is 1. Number two, when you use this standardized, whether you perform with the Lizril, whether you perform with the smart PLS, you will get approximately same answer. But unstandardized, you will be all three will give a different result. But the smart PLS will not give unstandardized at all. Smart PLS will not give unstandardized. Other softwares, they will give unstandardized. But unstandardized produced by different software will be different. Because the mechanism used for estimation will be different. But standardized, all brought into a standardized form, then it is run Nothing will happen. So that is why today we are going to use all standardized only. That is why I did put here, when I look at it, I have put only the standardized regression weight. Okay. So now I have a correlation, right? Now, what I am going to do in the CFA, I am going to check the validity. What do you mean by validity? Now you have put the questionnaire to collect the data. Now we are going to check whatever we have put is right or wrong. Whether our questionnaire is valid. That is why confirm. We are confirming. So confirmatory factor analysis is meant for validity checking. What do you mean by validity checking? Whatever the instrument we have used is valid. Okay. So then this is very essential. Why? Because when the instrument itself is not good, then if you use analysis with that data, how can you rely upon the result to be produced by that unvalid questionnaire? So that is why this validity checking is very, very essential. Very, very essential. Okay. So that is why I used to tell all my scholars to put this validity checking in the methodology chapter before analysis. So only path analysis we will present in the analysis chapter. So these are all checking the validity. Okay. So now, okay, now normally when it is a physical mode class, I will tell a story, but let me tell. Now we have started learning this one, mainly to learn this validity, not to that regression, all these things. For that, we have done regression by putting consolidated score, all these things. But we do not have mechanism to test the validity without understanding this SEM or AMOS other softwares. So that has motivated us to learn, right? Because I used to tell that also, because when my guide has produced the first scholar, his examiner, foreign examiner, has asked a question. What is the question he has asked? I do not know. Let me read the same sentence. I do not know how the guide has allowed the scholar to do analysis without checking the validity of the questionnaire. That is the question asked by the foreign examiner. So since he has asked the guide, okay, how guide has allowed, he has asked me to put validity checking. How I have done a validity checking without understanding this one? Okay, because at that time I didn't know this one. So what I have done, that is a great story, great story. Okay, so let us not waste time on that. So this is very, very essential. That is why this software or some has become popular, because it is a must. It is a must. Two things it has become must. One is we have started using construct. That is one. Then validity checking you cannot do without understanding this. Okay, that is why it has become a popular. Now, how I am going to do now? Now let me tell each validity. Let me tell each validity. Right. Now output is ready. Okay. Now output is ready. Okay. Now I am going for each validity. One is called item validity. What is item? Each item. And fine. That is the one item. Otherwise, let me go to the diagram. Here comes 1, 2, 3, 5. These are all each item indicator, each statement. Now I want to tell each item is valid or not. How to tell? How to tell? Now we say we feel concern 1 is related to this concern. We feel, that is why you have put that item under that constraint. Now, this is my factor loading. What is factor loading? This is item. This is a factor or constraint or dimension or domain. So now this item or statement is loading here. How much is loading? 0.29. Okay. Otherwise, this item related with this one only 0.29. Only this much is loading. Remaining is not loading, not going inside that construct. So now this we call it as loading or relationship of this item with this one. Okay. So now if this is 0.2, which means only 20% going there, going inside. Okay. So if any of the item is loading less than 50%. Now, many people, they say it should be more than 0.70%, which means more than 0.7. But, okay, let me have some lenient approach. So, let us have at least 0.5. If any of the item is loading less than 50%, which means that item is not relevant to this one. That is the meaning. That is called an item validity. What do you mean by item validity? This item should be valid, which means this item should be related to this one. Okay, so the item should be talking about this one. The item should go inside this one. If it is not going inside, which means this item is not valid. So we have to look at all these factor loadings, okay, standardized factor loading. We are looking at standardized. All the standardized factor loading should be greater than 0.5. So the standardized factor loading, we call it as a lambda. Okay. Otherwise, this is the relationship between concern 1 and the item to factor related. All items should be related to the factor symbol. Okay. So respective factor. That is the item validity. Now let me go to the another validity, face validity. Right. What is face validity? Now normally, after preparing a questionnaire, what we will do is we will take that questionnaire, we will give it to some expert. Now people are in this field. So to find out whether the questionnaire is good, sir. And then that gentleman asked, what is your title? Okay. So, you want to measure supply chain competence, the relationship among the supply chain components, right? Okay. What are the components? Okay. So these are all the possible components he is having. The items are relevant. Okay. So he is having sufficient item. Okay. So now by looking at the face of the questionnaire. Okay. Then the judge, okay, that is the expert. He will say, okay, questionnaire is vacuum. Okay. That is called face value. Okay. So whether the items are relevant to the construct. He will look at it and he will tell. So now what is content validity? Okay. What is content validity? Now, content validity and face validity is similar. Both are judged by expert, but content validity, the judge will go in detail. Okay, he will ask, okay, now what you are going to do? How many concepts you have? What is your hypothesis? Okay, so whether this hypothesis relevant to the constructs, right? Very good. What is the objective? For objective, whether you are having construct, right? Whether sufficient items, okay. So when you talk about concern, probably inventory management, there will be one concern. Then transport might be a concern. Distance might be a concern. Okay, storage might be a concern. Whether you have looked into all those things? Yes. Okay. Which means the content, each and every aspects. We will look into that and he will judge whether the questionnaire is okay. Okay. So that is called content validity. Next, now we are going for a calculation, right? Okay. Now we have a convergent validity. That convergent validity is measured by AVE, average variance extracted. Now let me read what is convergent validity, right? So if you have convergent validity issues problem, then your variables do not correlate well with each other within their parent factor. The latent factor is not well explained by the observed variable. Okay, now what it is? Now you have a construct. You have a construct, right? Okay. Now each construct, item you have put. Now first you have seen item validity, whether each item is valid to that construct. Then what does it mean? Each item is having correlated with the factor. That is the item validity. Now whether all the items are correlated, okay? So whether all items are related, right? All other items. So now in a reflect model, reflect construct, all items are related. Now it will tell whether all items are related. Now what all items? Items which are within that factor. That is why we have to do each and every factor separately. Okay. So in that factor, whether all items are related, which means all converge. All are related means all are coherent. That is called converge, right? So, okay, so degree to which latent variable is explained by observed variable, right? So when all items are related, which means we can measure that, okay, average variance extracted. Now if you look at the formula, okay, so this is the each variable. Each variable. Now lambda, what is lambda? Standardized loading of each variable. Okay, so it is a square. That is why we call it as variance. Average. Okay, what does it mean? Under the each construct, if you have 5 items, add all these 5 items. How to be done? So now concern. So now we have a factor loading. Okay, so now add all these things. Okay, square, each square, or add all the variance divided by 5 because we have added 5. So next one, square and divided by 4. Okay, so that has to be done, right? So that is called average variance extracted, right? So when the average variance extracted is more than 0.5 average. Now here you need to understand. Right? So now what we are doing is we are taking square. Okay, suppose right? Okay, 0.5 square, it will become 0.25, right? So then if let us assume that all are just 0.5, then what will happen? 0.5 square, 0.25, you will add 0.25 divided by 5, then you will get 0.25. But what we want, it should be more than 0.5. When you will get 0.5, so if that each item loading is more than 0.7, 0.1 thing, right? 1, 2. So what will happen? 0.71 square, 0.49, approximately 0.5. If you add divided by 5, you will get 0.5. So that is why if each value is more than 0.7, it will be 0.5. Okay. So yes, we are allowing 0.5 because if one item 0.5, if one item 0.9, that will get compensated. That is why we have a leniency of allowing each item is 0.5. But some item will be more, average will be compensated. If any of the item is less than 0.5, that item is not even loading 50%, which means that not fitting here. Nothing. Okay. So that is called convergent validity. That is called convergent validity. Okay. So now we will go to the another validity. All right. Okay. So let me complete composite validity and I will come back. Right. Okay. Now we have a composite reliability. Okay. Otherwise, composite validity. Otherwise called construct validity. Okay. Now I have a formula for this one. Right. So now how it is calculated, I'm going to tell now. Now you know what is lambda. What is lambda? What is lambda? Right, very good. Now you know what is lambda here. What is lambda? Standardized loading. All right. Now here, their squared added divided by 5. Now here what we are doing, okay, we are adding, then squaring, which means we are trying to find out total. Is it okay? Is it visible, sir? Christo, sir, is it visible?
Yes, sir. Yes, sir. It is visible, sir.
Okay, very good.
Yes, sir. Yes, sir. It is visible. Opposite
Okay.
reliability. Yeah.
Yes, sir. Yes, sir. Good, sir. Good, sir. Very good. So now we are going to. I'm going to teach. Okay. What is this formula? Right. Okay. So now lambda standardized loading. Let us have 5. Add the loading, summation of loading, then square. Okay. Then what? This is the total measurement. Total loading. Right. Total measurement divided by total. And here this is error, which means this is a measurement. This is measurement plus error. So which means in the total, what is measured? So look at this one. Lambda is loading each measure, right? Each measure loading average, which means total how much we are measuring that constant. Now this is again same thing, which means what we measure. This is error, what we do not measure, right? So what we measure and error, total. Total, in the total, what we measure, okay. So if it is more than 0.7, it is okay. Now see here, error variance, square, error variance. It itself variant, so simply summation, right? So what is this error? What is this error? How it is calculated? Right? So now same formula I have, same formula. For the sake of simplicity, I am taking a construct which is having less number of items. Which is having less number of items? Supply chain performance, SCP, right? Okay, that, okay, now SCP, now. This is correlation now. Okay, now SCP loading. Okay, please try to remember 0.537, 0.677, 0.836, only 3 items. Okay, only 3 items. 0.535, 0.677, 0.8. Okay, now let me put that. Okay. 0.836, 0.677, point this. Right. Now what we want? Summation, then square. Okay, this is a summation, then square. Now summated value 2.048. Then squared value 4.194. That is there. Now numerator is ready. Okay, this is ready. Adding, then squared. Very good. Next one. What is error variance? Error variance is 1 minus lambda square. Okay, now we know this one. Now we do not know this one. Now what is this lambda? Lambda is equal to delta. Delta is equal to 1 minus lambda square. Now this is square. After square, 1 minus. So these are lambda. Square, loading, square. 1 minus lambda square. 1 minus lambda square, right? Now summation, this value. Okay, now I have this value, right? Okay. Now, what is my question? Now I have a numerator. What is denominator? This numerator plus this 1.57. So which means 4.194 divided by 4.194 plus 1.57. Okay. So this is the calculation for construct reliability. Okay. So now this should be more than 0.6. This should be more than 0.7. Now look at this. What is this value? More than 0.729. 0.729, right? So this is calculated 0.729. Now you know how to calculate. What is this? What is this composite reliability? What is this composite? Okay. Now what we are doing? Okay. So if you understand, then you will understand. We are measuring total. Okay, divided by total, entire total. Total measurement by measurement plus, which means we are measuring 70%. Out of that total, our measurement is 70%, which means we are measuring the construct. We are measuring the construct, which means whether we are sufficiently measuring. We are sufficiently measuring. Now, look at this one. Each item is loaded. Okay, very good. All items are related. Very good. Now, that construct itself, we are measuring sufficiently. Okay. So, this is composite total reliability. When you say composite reliability is okay, which means our construct is okay. Our construct is reliable. Right. So, now
Kasilingam sir, you are muted, sir. Sir, you are muted.
is it okay, sir? Is it visible, sir?
Yeah, it's visible, sir.
Okay, very good, sir. Okay. Now I'm
High validity.
now the divergent validity, right, sir?
Yeah. You're right, sir. You're right.
Very good, sir. Very good, sir. Now, okay. Now, divergent validity. What is this divergent validity? Now, you have a supply chain concern. You have a supply chain competence. You have supply chain performance. Why you have three? Because you feel they are different. You feel they are different. Okay. So, which means they should be different. When we will call they are different? Okay. When they are not related. When these three factors are not related. When we will say they are not related? See, we cannot say they are not related. Well, then how come each domain cannot be related? It will be related. But now look at the what is the definition says. If you have discriminant variety issues, then your variables, what is that item? Your variables, okay, correlate more highly with variable outside. Which means each item should load more into the factor, that latter variable. You should not load more into the other one. If it load more into the other one, what will happen? This concept will be more related to that, because this item loading here, they are loading there also. Then relationship will be more. So now all these items should load more here rather than there, which means okay, don't worry about that. So now these items loaded, okay, related, that is measured with the AVE, right? AVE. Items related with that factor, okay, overall, okay, average, that is measured with the AVE. Now, the AVE, okay, of that construct should be greater than its relationship, that is construct relationship with other constructs. Okay, now I will take. Now let me go here. Now, for example, we can find out AB for this construct. How we can find out? Each one square, adding, divided by 5, I will have AVE, right? So now that is the AVE for this one. Like that, I can find AVE for this one. I can find AVE for now. This AVE should be greater than, now this construct is related here. This construct is related here. So this should be greater than this value 0.14 and 0.01. Then this item is a different for this construct is different from other construct. That is the divergent. Simply, the people used to say all items should converge, all factors should diverge. That is the final meaning. What you mean by all items should converge with the factor? Each factor should be diverse. Right. So now people are giving some leniency, right? Okay. What is the leniency? Now, ABE should be greater than correlation. That is what we want. But what will happen? What will happen? People are having problem. Then they are asking you to square this one. Correlation square. What you mean? See, please remember, this should be more than this one. Now, we are taking correlation square. When you take correlation square, what will happen? Always we used to say, correlation means it is between 0 to 1. So, all are in points. If the correlation is 0.5, if you square it, it will become 0.025. Okay, 0.2, it will be reduced. 0.5 means it will become 0.25. It will be reduced. Okay, so we want this should be more than correlation, not happening. At least we square these values so that this will come down. That value will come down. At least in that condition, this should be more. Otherwise, right? Now this should be more. Then it will be more. This also, AV also in points. Square root. If you take square root, then this will be, it will rise. Okay, this will rise. It should be greater than correlation. Anything you can use. Anything you can use. But higher books, they are using this one. But in the calculation, we are using this one. Anything can use, no problem. Okay. Okay. Now, we have one more. That is called shared variance. What is this shared variance? Shared variance. Now, each one variance, lambda square. Shared variance. That is the correlation. Now, look at this one. To what extent a variable can be explained by another variable? Because of that correlation. So, if the correlation between two variables is 0.8, then the shared variance is 0.64. Adding. Okay. So, now, discriminant validity, not only this one, I am going to tell something more. AVE should be greater than correlation square, or squared AVE should be greater than correlation. Then we have two, MSV and ASV. Suppose, what is MSV? Right, let me tell you MSV. Now I have a correlation, right? Okay. So among this maximum, this is a correlation, right? We say square, right? Okay. Maximum among these two, this is maximum. That alone will be taken. Okay. So here this is maximum. That is squared. Okay. Only that divided by. Okay. So that here average means taking two. The square of that average you find out. Average shared variance. What is shared variance? You please read the shared variance. Shared variance is correlation square, right? Correlation square. Only maximum value you have taken. Okay. Otherwise, average. Adding divided by 2. Average. Okay. That is fine. Now, AVE. Always AVE. That measure. AVE should be greater than MSV, or AVE should be greater than ASV. Average variance extracted. Okay. Maximum shared variance. Very good. So now, this is the formula we have explained. Okay. So this validity I will come. So now for this formula, how it is measured. So each one was squared 0.36 KR, all these things it is given. Okay, so now these are all the critical values, right? CR value should be greater than 0.5 for convergent validity. AVE should be greater than 0.5. CR should be greater than AVE for discriminant validity. So AVE should be greater than correlation square. So AVE should be greater than MSV. AVE should be greater than AS. AS. Okay, so these are all the okay. Now, okay. So now, if you have any doubt, please tell me. Okay.
Kasiram sir. Hello, sir.
Yes, sir. Yes, sir.
Sir,
Yes, sir.
if the standardized factor loading or lambda is less than 0.05, in that case, should we not drop that item and rerun CFA to improve the fit measure, sir? So is it like this, sir?
Yeah, you are right, sir. You are absolutely right, sir. You are absolutely right. Now,
because in one of your first supply chain, the first item was having loading of 0.29, so it should be dropped.
yes, sir. Yes, sir. Yes, sir. Now, okay. So now what to do? Whenever, okay, I'm going. Still, I have not completed because if I take still more time, you will be boring. That is why I have stopped here. Okay, still I have not completed. But let me tell you, whenever you have any issues, what are the issue? Item validity issue, AVE issue, and CR issue, and discriminant validity issue. All the four. These four are calculated. We have something more like content validity, normal-checker validity, unit-dimension validity, like that. That I didn't tell. I will tell later. Okay. So these four are calculated with the figures. All right. Very good. Now, let me ask one question. Okay. Very intelligent question. We are calculating two things. One is AVE, another is CR. What is AVE? Please try to remember. Square adding divided by n. Okay, a CR adding, squaring this one plus this one. Right, very good. Normally, which one will be a trouble to you? Among this AVE or CR, which one will create a trouble?
Sir, I think composite reliability can create a trouble if the respondents don't give a good response.
No, leave alone the respondents, sir. Now we are calculating, sir. Okay, now it is not CR. Only AVE will create a trouble. AVE will create a trouble. Why AVE? Because, see, please remember, all our loadings are in points. All our loadings are in points. Okay, 0.5, 0.6. We are squaring. What do you mean by we are squaring? Which means we are reducing. 0.5 will become 0.25. So 0.7 will become 0.49. Okay. Then you are adding averaging trouble. But in CR, what we are doing? 0.5, even all are 0.5. If 5.5, total will become 2.5. Then you are take the squaring. Because when you add, the value will become more than 1. Then if you square, if it is 2, if you square, it will increase. It will become 4. It will become 2 will become 4. Okay, that is why always CR value is not a big problem. AVE value will be a big problem. If you get the AVE, okay, then which means all problems are solved. Simple. All problems will be solved. Okay, so that is one. Now, if you have any problem, then among the all constructs, which that AVE problem, everything is coming because of loading only. Because of loading only. Okay, because loading only we are calculating. So you remove item whichever is having very less first. Whichever among the all item, remove first one, run. Then find out which one. Remove that, then run. Remove that, then. These are all process. So finally, you are going to show the final one, which is very good, accepted one. Okay, so all items should be deleted. All items, one by one, you should delete. One by one, you should delete. Okay. Now, here you should be very careful. One gentleman, when I went to NIT, one gentleman, he has put some 49, some 50 items totally. He said, I have removed around 20 items. What does it mean? Okay. So he has collected from the our collected data, 50% data he has removed. Okay, then what opinion you will derive about his questionnaire construction? Okay, that also should not happen. That is a very long. Okay, so we can tell it one or two. So that is why we have to be very careful. Okay, after reviewing 30 questions, you should perform Cronbach alpha. Right. So then after 100, you perform this one with smart VLS. Like that, one by one, you have to do one by one. Then, okay, that time itself we can change, we can make modification so that finally you will not land up in very high trouble. Okay. So, okay, let me not confuse much. Simple. As Arun sir said, if you have any problem, okay, so you calculate all. Where you have a problem, you remove that item, then you run. Okay, slowly you do this process. Very good. So, any more questions, sir? Now,
Sir,
whether
one
you have
question.
understood. Okay, I want to know whether you have understood two things. I want to know. What is CFA? That you should have understood. CFA meant for validity checking, that you need to understand. Here we are measuring 3 validity. What is the meaning of those validity? You need to know, sir. Okay. You need not worry about the calculation because I am going to tell another simple form, sir. Right. Very good. Now tell me, sir. Any questions, sir? Yes, sir.
Sir,
Yes,
I
sir.
have a question.
Yes, sir. Yes, sir.
Can we minimize that wrong item selection, or maybe those item with lesser value of 0.5, which you are talking about,
Yes.
by selecting some already standardized scale items, which has been studied earlier in literature, maybe, or in different settings?
Yes, sir. Yes,
Because
sir. Yes, of course, sir.
Yeah, most of this problem occurs when we have a scale item which is not been studied, or which has been randomly selected from here and there. So that point of time, it may not be correlated well with the construct.
No. What you are trying to tell, sir?
So I am trying to say that instead of having any rampant scale, or designing our own scale without testing it, should it be recommended to use a standard scale or item scale which is already been tested somewhere about its validity and consistency?
So now, sir, there are issue number 1. What is the issue number 1? Whether we have to use the standardized questionnaire or we have to use a new one. That is the question number 1. If you have already standardized, use that standardized.
Yes, sir.
Oh, absolutely no problem. If you do not have, okay, then develop a questionnaire. Okay.
Yes, sir.
That is the number 2. Number 3. Even if you have used a standardized questionnaire, they have developed the standardized questionnaire in some other country.
Yes, sir.
Their setting is different.
Yes, sir.
Our setting is different.
Yes, sir.
So that is why we are checking. Now,
Yes.
Finally, after that time, there will not be much problem because the statement sentence used by them might be different. So we need to make some alterations here and there, right? So there also you will get a problem. Now, for example, but I used only limited item. So this gentleman, whatever we have used the supply chain, he has taken from the questionnaire only. There he has used only tested. But even then he had a problem. We have removed.
Yes, sir.
We have removed some of the item. Then we got a reliability. Okay. So that will be there, sir. That will be there. But it will be minimum, sir. It will be minimum. But definitely, every case there will be a problem, sir. You need to remove one or two items, sir. That is why. Okay, one request to all: don't have three items one construct. Then finally you will not have any item to remove. Okay, so you put five, six, so that you will have some flexibility, sir. Some flexibility.
Yes, sir.
Okay, so very
Thank
good.
you, sir.
Okay, very good, sir. So now let me go to the yesterday I was talking about one stat tool pack. Now I am going to use that. Now it's very easy only, but when this supply chain gentleman whose questionnaire I am showing, so he is working in Bangalore only. Okay, so he is Mr. Ganesh Kumar working with the Indian Institute of Plantation Management. Only his questionnaire I am using. Okay, so now what happened when he was doing PhD? We have calculated all these things. We have calculated everything. So what is the formula? What is this lambda? That itself it has taken time. Then what is this error? It has taken us very lot of time. What is this error? Because SPS, that Amos itself giving something as error. Whether this error, that error, we had a lot of confusion. But finally we have calculated that is a story. Now, when after understanding the problem of all these research scholars, okay, there is one gentleman, right? What we are then, so that gentleman name, okay. So yesterday I was talking about that gentleman, okay, James Gaskin. So he has developed this stat tool pack and he has given to us. We are going to use that stat tool pack, right? In which, okay, in the stat tool pack, we are going to use validity master, under which it will ask for a correlation. Why we ask for a? Because in the discriminant validity, we are checking with correlation, right? The AVE, right? AVE should be greater than correlation square, right? Or otherwise, the square root of AVE should be greater than correlation. So we require correlation. That is why we have clicked the correlation there. If you have not clicked the correlation, correlation will not come. It is not automatic. Only unstandard is automatic. Standardized you have to click, correlation you have to click, right? So then that is required. Then what is another requirement? Standardized loading. Because only by using standardized loading, we are calculating lambda, we are calculating AVE and CR, right? Okay. So these two required. Okay. So now one more request. Whenever you have a factor name, that should not be F1 or that is concern 1, concern 2, something like that. You should not have. You should not have, right? So otherwise there will be a problem, right? So now, okay, now output. Now I am going there. I am going to start tool pack, right? Structural equation. Start tool pack. Okay. Okay. So now here in this start tool pack, here you have many, right? Many things he has given. But what I'm going to use? Validity master, right? Okay. So yesterday for moderation, we'll be using group difference to find out each group is different. Then overall different, that we have used threshold. Okay, we have used threshold, constraint model and other model, right? So we have a validity master. Under validity master, now see here. Now they will be telling you, you need not worry. First it is telling test correlation table into A1. Okay. So now let me go to the output. Let me go to the output. Here I have estimates. I have a correlation. I have a correlation, right? I have a correlation. Okay. So right click, select, right click, copy. I'm going here. I'm pasting here. Pasting here. Paste. Done. I have pasted correlation. Then what it's telling? Standardized regression weight in F1, right? Okay, let me go here. So let me go to standardized weight. Standardized weight. Okay, so okay, now I have where I have to paste into F1, right? Let me go to F1 and F1. Let me paste it. I paste it. Now see here, it is telling many points. Your later variable does not end with number, right? You should not have name as any factor name should not be E and good AVE, MSV, OR. Okay, your factor name should not be OR, right? Because all are reserved words. Okay, now it is okay. Now then click, right? I'm clicking. Okay, now ready? Now you have one table. Okay, you need not remember anything. Alright, you need not remember anything. What you need to know is what is conversion variety, what is divergence. Only those things you need to know, because all other things it is teaching. Now, if you see here, there is a discriminant variety issue. These are all problem. What are the problem? The square root of AB, it is telling, it is taking square root of AB of this one, competence is less than, which I told you, no, in a discriminant validity, the square root of ABE should be greater than correlation. Now, see here, competence and yes, okay, here, this is greater than this one. That should not happen. That is it, point number one. Now, point number two, CR is less than 0.7 for concern. CR for average, this is less than. Now, if you see here, okay, see here, you see here, all ABE we have problem. All ABE we have trouble. Okay, but CR we have trouble for 1, 2. But conversion variety we have trouble with only 1. Okay, okay, now. Okay, so let me go there and let me put it into the. Okay. Okay, now let us see here. This is what it so. Look at all ABE. We want all ABE should be greater than 0.5. We have a problem. That is what conversion variety here for problem, conversion variety for competence problem, conversion variety for SCP problem. All three problems. That is what it is telling. It is telling in CR, that is the conversion, that is the reliability. CR problem. Okay, then CR for competence problem. This is no problem. All right, that is fine. Now, in a discriminant variety, okay, in a discriminant variety, what is this one? Right? What is this one? Okay, what is this one? Please remember, what is our formula? We will compare square root of ABE should be greater than correlation. Square root of AB. Right, very good. We have three constraints. We have three constraints. Now remember the correlation value. Please remember the correlation value. 0.143, 0.609 minus 0.10. Right, very good. Now we will go to the discriminant. This you can understand, but even then, let me try to explain. We will hold this up to this one here. Consent, competent, SCP. Now here also, row, consent, competent, SCP. Column. Okay. Consent versus consent. This is 0.546 because what we have to compare? We have to compare square root of ABE with correlation. Now, this is 0.546 is nothing but 0.298 square root. If you put a square root of 0.298, you will get 0.546. Now, what is 528? Square root of this one is 0.528. Square root of this one is, okay, now ABE, these are all the square root of ABE. Now, concern is having correlation with competence. What is the value? 0.143. These three are correlation. See here, 0.143, 0.690, 0.0. So, now this value should be greater than these two values. Greater, no problem. Now this one, competence, right, should be greater than concerned relationship. See here this value, relationship between concern and competence. This is value. Now what is this value? Competence and supply chain. So this value should be greater than this value and this value, but it is less. That is why red. This value should be greater than this two. So greater. All right. So this is the divergent validity. This is the divergent validity. Right. Very good. So this is the validity master. Now we will go with other two. Okay. Now how it is calculated also it is explained. Now if you see here, okay, I have taken some data. These are all the or some example. These are all my standardized loading, right? These are all my standard loading. This is my correlation, right? How AB is calculated. See here for concept A, 0.65 square, 0.65 square, 0.56 square, 0.57 square divided by 3. 0.65 square, 0.56 square, 0.57 square, addition divided by 3. That is AB. Now, what is MSC? MSC is that is with the relation with other square. Okay. So now 60, right? If you take here, this is having relationship with this one. This is having relationship with this one. So here maximum relationship this one. Shared variance means square. So 0.6 square. So that is the maximum shared. What is average? Square of this one and plus square of this one. So divided by 2. Now that is what that. So square of that plus square of that divided by 2. Okay. What is CR value? 0.65. Okay. So what is 56? 1 minus that lambda square, right? So here we will 1 minus lambda square. This one 1 minus this is a lambda square. Like that calculated, right? Like that calculated, added. Okay, so this is a loading square, a loading addition square divided by same thing plus lambda. Okay, so like that example is given. What is how it is calculated? That also you can use it. Now we have 2 more validity. These are all not calculated. These are all telling what is unit dimension. Only one dimension. What do you mean by only one dimension? For one aspect, you need to have only one dimension. Okay. So whenever we talk about personality, only one dimension. Whenever you talk about consent, we need to have only one dimension. Right? Only one dimension. So all items you should put. You should put maximum item to measure that construct. So that is what it is written. Okay. So it's an important assumption in a number of areas of this one. There's an implication of this is actually measured by this one, right? So for example, if you have assessment that designed to measure math ability, we should want to ensure that all questions in the assessment measure of this construct only related to this construct. Okay, all items we should all items. Okay. So only this constraint, not any other constraint. And we have a nomological validity. What is this nomological? So this is what they have written. Nomological validity examines whether the correlation between the constructs in the measurement theory makes a sense. What is this one? See, now we have two constructs. We will say they are related. Okay. So nomological means law of nature. That is the law of nature. Whenever you tell they are related, it should go along with the nature. Okay, it should not go against the nature, law of nature. So that relationship should be valid. It should go along with the natural relationship. It should not be something contrary. It should not be something contrary to the law of nature, natural law. That is the nomological justice, right? So this also, whenever you get to some relationship, you should show to the experts and to find out whether this relationship is nature, something like that, right? But different people will tell different this one. That's also possible in the nature. This also possible. That also possible. That is a different one. That is a different story. But that is what the validity is. So these are all tested with. This is tested with the experts. But unidimension, only one dimension, right? So with this, we are completing the validity checking, right? Very good. So now, if you have any questions with respect to total validity checking, we can go, right? So otherwise, I am going to take one more example. With that, I will complete. Right. Very good. Yes, sir. Any questions?
So there is no question in the chat box, but dear participants, if you would like to raise any questions, you can unmute now. I give you 2 minutes or 3 minutes. You can raise your questions, or else we can go for the next example.
Yes, sir. Next example, probably I will not draw, sir. Yes, sir.
Yeah.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Slightly, I have a slight confusion, sir.
Yes,
Sir, when you give example of that supply chain construction also, the researcher should have first gone for EFA, then he should have gone for CFA. Because had he gone for EFA, in that case, the correlation between the factor would have been 0, sir. Sir, what is your take, sir? I'm slightly confused. Because how could a researcher, without checking for factor analysis, straight away go to CFA? So maybe, sir, can you throw light on it?
No, sir. See, CFA and EFA is a complementary, sir. When you perform EFA, there is no necessity to perform CFA, sir.
How am I going to check the validity?
Sir, no, sir. No. Not necessary, sir. Because all are related, sir. When we are doing factor analysis itself, all related items only loaded there into the factor. Then we will check the commonality there. There we call it as commonality, right? Total variance, how it is going. When the commonality is more than 0.5, but less than 0.5, we will remove there itself. So which means, once you have performed EFA, after that, if you perform CFA, how do you get a problem, sir? You will not get a problem at all. You will not get a problem at all, sir. Now, when we will go for EFA, when you will go for EFA, when you have not given factor in the questionnaire. All right. So please understand, sir, we have to be very careful. Right. We have Shanmugapriya madam from Annamalai University. She might ask that question now. See, for example, you have a valid, that is a tested questionnaire, sir. You have a tested questionnaire, right? So one factor he has put, another factor you have put, another factor you have put. Now what you are going to do, in a factor analysis, you will not put each factor. All you will put one. all you will put 1. Then, if you perform factor analysis, what will happen now, sir? In the questionnaire, for example, he might have put A1, A2, A5 under one construct A. B1 to B5, he might have put under B. Now, if you do factor analysis, A1, A2 will be in factor A. B1, B2 also will be in factor 1, sir. There will be, you will end up with confusion, sir. Can you see, when you have used already, when you use the tested questionnaire, use only CFA, sir. Okay, only CFA. Then only you will not have any problem. See, if you combine all the statement, then if you perform factor analysis, the grouping will be different from what is the grouping given by that tested questionnaire, sir. That don't perform, sir. You will end up with the confusion, sir. Don't perform.
Okay, sir. Okay.
Okay, when you have a tested questionnaire, use only the CFA. Right, very good. Now I will tell one more. Suppose that not advisable, but suppose. Because that we will be going against the unit dimension. Suppose, okay. You have one construct under which you have a 14 statement, 15 statements. Okay. Then drawing diagram and you will have many issues. You will get this validity and all will be a very big trouble, sir. Okay. So that time what people will do is, okay, there please understand, I am not telling you to consolidate all the statement and do factor analysis. Don't do. Within one factor itself, that person has put 14 statement. Now you subdivide that factor into 3 subdimension, for which you do factor. Okay. Then if you do, okay, so CFA, nothing will happen.